Well, guys, we made it to Tuesday. Looks like the camera didn't pass the math test here. That's okay, isn't it?
Okay. Hey guys, quick review from yesterday, and then we'll get through these last two examples. I have a short, quick quiz. Yesterday I sent out the new online page. Did everybody find that in there yesterday? If not, it's not due until tomorrow night at 10 o'clock, so I should have plenty of time there. Okay. Let's see. Everybody should have notes then, I think. So, guys, quick review from yesterday. Anybody want to take a shot at that? Sam, what do you think, bud?
X to the 10th.
X to the 10th. You'd add the exponents. Whoops, and I can't even do that right today. All right, how about this one? What do you think, Logan?
X to the 5th.
X to the 5th. You subtract, right? How would I simplify this right here? What do you think there, Andrew?
X to the 15th.
Absolutely. You bring this into this one. This is a power of a power, so it'll be x to the 15th. Okay. How do I write this as something with positive exponents from yesterday? How do I express x to the negative 7th as something with positive exponents only from yesterday? Allie, what do you think, kiddo?
1 over x to 7.
Perfect. Okay. All right. Well, we're pretty good at this. Let's simplify some things. If you guys can get this right, I'll feel pretty good about this. I want to write that so that I have only positive exponents in simplest form. How would I go about this? And I'm going to need a good explanation on it. So, and I know you guys know how to do this. So, somebody volunteer to tell me how this works. All right, Logan, I'm listening, kiddo.
The 6 and the y to 0, that's just equal to 6, right?
Yep, because y to the 0 right here would be equal to what value, kids?
1.
So this is really 6 times 1 up top. All right.
And then the bottom is 2, or the bottom is 2x to the negative 1. Then you flip it.
Okay. So this x to the negative 4th, and we kind of talked about this a little bit yesterday, and I want to kind of hammer on this again real quickly this morning. I said if an exponent to a variable or some expression was ever negative on one side of the fraction bar, in this case the bottom, then this exponent would be positive on the opposite side. So this x to the negative 4 could move to the top, but it would change to x to the 4th, right? So help me up top. What's the 6 times 1 going to get you, kids?
6.
So I have 6x to the 4th over 2. But talk to me about that 6 over 2 part. Can that fractional part, 6 over 2, be reduced to anything that's in the simplest form? 3 over 1. Okay. So wouldn't this just in the end be 3x to the 4th right there? Okay. So in a nutshell, that's pretty much what we covered yesterday. Okay, that's pretty much what we covered yesterday in a nutshell. So what I'd like to do today is just finish up with our notes on the last page. I think we were on the last page. And, oh no, what did I do? I want this page to go away. All right, page 4 then. Okay. So, up top here, we've got a real life example. And it says, there's some expressions down here that say, which of the expressions shown represent the, what's the word here, kids? Volume of the cone where what? R is the radius and H is the height. Now guys, take a look at your radius down here from the center out. What do they change your radius to? Okay. First things first, you have a cone there. Anybody know the volume formula of a cone? Okay, if you don't, you know who does know the volume of every single shape? Who? Well, no, not even me. I bet Google knows though. Why don't you, somebody jump in the Chromebook. Andrew, are you in the Chromebook right there?
Yeah.
Type in this right here and see if it gives you a formula. Type in volume of a cone and see if it kicks out a formula for you.
Volume is equal to pi r squared times h over 2.
Pi r squared times h over 3. Okay? So here's what we have.
No,
We have
it was just the h over
oh,
2.
okay. I'm going to cheat this. Is that okay? I'm actually going to call this. If I divide by 3, isn't that the same as multiplying by a fraction 1/3, kids? So I'm actually going to call it something like this. 1/3 times pi times r squared times h. Okay, that's what we're going to call it. Now guys, they want to know which of these 6 expressions is correct down here in terms of the volume of this cone. What is the height, kids? We don't know, so they're just calling it what? Yeah, so we're going to say this here is going to be the part for height. And h over 2 is going to represent what, kids? So what we need to do is plug these values in for height and radius over in our formula and see what this simplifies to with our exponents. So here we go. My volume is going to equal, I'm going to write it like this, 1 over 3 times, guys, this pi is like pi over 1, isn't it, kids? So I'll put a pi up top here. Okay, r squared, this is an interesting one. What are we putting in for the radius, kids? So in for r, we're going to plug in what? Okay, so times h over 2 to what power, kids? Second times the height, h, which is just going to be what, kids? H. All right, this is a mess. Total mess. But I think we're going to get it. Okay? So here's what we get. We still have this 1/3 part as our formula. Times pi. Is the pi up top or in the bottom? That's really up top. So times really pi up top times, okay, help me square h over 2. What would h to the second power be up top? Just be, well, what's h over 2 to the, what do I need to do here, kids? Call it h squared, don't I? And I need to square what other value here?
2.
Which is times another h, which is left up top. So let's see what we get. This is a mess. What's 1 times pi, kids? Pi. I've got h squared times really h to the first up here. So by rules of exponents, what's h to the second times h to the first up top? So do you guys agree that we have 1 pi h cubed up top? What are we going to have in the bottom here if I have 3 times 4? What are we going to have in the bottom for 3 times 4? So the question becomes, given these conditions right here, if the height is h and the radius is h over 2, knowing that this is my volume formula, after we plug stuff in for radius and height, which of those 6 answers is the right one for the volume with the radius and that height? Do you see anything over here that matches what we got? Very first one, right? Isn't that a good feeling when you get an answer and then you look over to see the matching ones and there's one that matches? Have any of you ever done like me? Lots of times when I was a kid, it's like, I got an answer, but it doesn't match any of them. Anybody ever done that? You guys wouldn't do that. You're way better than I am. I do that a lot, okay? How many of you guys take multiple choice tests in math? Have we done multiple choice tests in here yet? Heck, we haven't even had a test yet, have we? Ooh, we could have one of those pretty soon, I think. Gage is shaking his head yes, because he should be on. If you're gonna shake your head like that, lay on your side and do that, okay? His uncle said yes. Alright. That's a tough problem. How many agree that that's kind of a tough problem? Okay, we had to find the volume formula, but once I plugged stuff in, didn't all of our rules of exponents kind of take over here? Okay. Alright, let's talk this last example, scientific notation. Then I'm going to get you moving on a few things to see how well we can handle this stuff. I don't like number 6, but we're going to do it. Solving a real life problem. What types of notation are these called right here again, kids? Scientific notation writes numbers as a base of 10. In other words, this first number right here is always a number between 1 and 10. And then they always write it times 10 to a certain power. Now when I multiply it by 10, it's like moving the decimal point either right or left. Okay? Think about it. What's 2 times 10? 20. Take 2 and move the decimal point right 1 unit. 2 turns into what? 1. Okay? Well, right here in this example, it says a laptop computer uses approximately 8.4 times 10 to the negative 3 kilowatt hours of energy in 3.5 times 10 to the negative 1 hours. It says how many kilowatt hours of energy does the laptop use per what? We're taking the number of kilowatt hours per what? Hour. Okay? It says to write your answer in scientific notation and then in standard form. I'm going to give you guys a hint on this. Don't ever start in scientific notation. Always start in standard notation. Turn stuff into decimals first to make this work. Okay? So here's the situation. Which of these two numbers in scientific notation, the first one or the second one, represents kilowatt hours? We need to take 8.4 times 10 to the negative 3 divided by the number of what, kids? Per what? Hour. Which one of these numbers in scientific notation represents the number of hours? Second one. So 3.5 times 10 to the negative 1. Okay? Now, here's what we're going to do. This said give me an answer in scientific notation first, and then what? We're going to do it in the reverse order. I always think you should do standard form first to get an answer. Okay? So here's what we're going to do. Let's change these to decimals. So guys, when I have 8.4 times 10 to the negative 3, this negative 3 is saying to turn this into decimal form, you need to take this decimal and move it what direction first? How many places? Well, one move puts me out in front of the 8, so how many zeros are going to be out in front of the 8.4? Okay, so this is the same as saying 0.0084. And this will be kilowatt hours, abbreviated kWh like this. And then, in the bottom, we need to change 3.5 times 10 to the negative 1 power to a decimal. So what is this saying to do to the decimal point, kids? Left how many units? So 3.5 shall become what? 0.35 on the bottom. This will be 0.35 hours. Okay? So our standard form answer here, kids, or decimal form, I can't spell either, hence the math teacher in me. Who's got a calculator handy? Oh, you know what? Parson does. Check this out. Oh my goodness. Whoa. What do I want to divide, kiddos? What divided by what? To get a standard form answer, decimals. 0.0084. Divide that. Oh, sharp the captain the kitty. Where's the delete button? Up above. Help me.
Top right corner.
This one? Good thing I'm not playing darts today. I can't even hit the right button. Huh. What are we dividing by? Yeah, we're going to divide this by 0.35. So here we go. And in standard form, I know the question is like, oh, I don't know what kilowatt hours are, and I don't know what hours are, but I do know that an answer in standard form looks like what, kids? Point what? 0.024. And then we would get kilowatt hours. How many kilowatt hours per what? Hour. So this is going to use 0.024, which we abbreviate kilowatt hours per hour here. That's the answer in standard form. Now, once I have my answer in standard form, all I did is I took these numbers, turned them into decimals first. Perform the operation. Division. It's division because we're taking something per something. Now I need to take the standard answer and put it into what, kids? Is it okay if I abbreviate scientific notation and just call it SN? Is that okay with you guys? Okay. My question to you guys is this. Within that answer that we got in decimal form, or standard form if you will, where would you have to place the decimal to make that value between 1 and 10 first? Okay, how many agree in between the 2 and the 4, what Andrew said here? Few people agree. Because we want that first value to be between what and what here for scientific notation? 1 and 10. Morning, Mr. Tongas. Had so much math yesterday, came back for more, huh?
I absolutely did.
I love it. Okay. So this is going to say, what do I want to write out front, kids? Okay, louder, Logan. 2.4. All right, this is the part where people can struggle a little bit, so let's try and make sure we're okay with this. He's saying place a decimal between the 2 and 4 to make that first value of scientific notation between 1 and 10. Now, where is the decimal currently at in our standard form answer? 2 to the left. So 1, 2. So if I want to write this as a base of 10, definition of scientific notation, then I'm going to write this times 10 to the positive 2 or negative 2?
Positive.
Okay, we've got a little argument here.
Because you're going to the right.
I'd say positive. I'm with you.
How many are going positive here?
Yeah, thank you.
Aw.
Did you see Daisy?
How many are going negative?
It's Daisy.
But once you move it back, so you.
Yeah,
You're going backwards.
Oh, shoot.
Okay.
That makes sense,
Yeah, that makes more sense.
Okay.
Okay, Logan, we can.
All right, let's talk. Let's make sure everybody's on the same page. Guys, look at my answer right here.
It's gonna be positive.
My answer in scientific notation, let's do what the exponent says right here. Let's take my decimal and move, according to what we have up here for an answer, what direction should I move that decimal point?
To the left.
1, 2. That would be 0.024. Does that match what we had up here? If I would have gone right 2 places, we would have had 20 or 240. Would that match this up here? Okay. So my question then is this. When they say write your answer in scientific first and then go standard, I'm suggesting you do what first? I think it's, look, we work with normal numbers, standard form numbers all the time. We don't work in scientific notation very often. So doesn't it make sense that we should work in standard form first?
Yeah.
Change everything over. Change your scientific notation into decimals first. Perform your operation. Once you have answer, come back and then rewrite that in their scientific notation. Okay? Cool with that? Okay. What questions do you have on the notes? First thing. All right. Secondly, just a reminder, I sent out a new online page for, this is 1.4, right?
Yeah.
For 1.4 to be due at 10 o'clock tomorrow. Tomorrow's looking like a work day with stuff, okay? And a little bit today even, all right? I do have a short, quick quiz I want to get to you first. I want you to do that first. And then the rest of the time, if you're into big ideas, if you have questions, come up and ask. I know Daisy has a couple of questions. 11, do you remember the other one?
72.
So when Daisy comes up, 11 and 72, if you want to see those 2 exercises, come on up with her. I'll be happy to show you those, all right? All right, so I guess the only thing I would announce otherwise would be that, remember the quizzes you got back? I think you got them back yesterday, right?
Yep.
I told you that if you weren't satisfied, how long to make corrections to that? A week, you can have credit back on that, so that would be good. So first things today, kids, quick quiz online, or in class, not online. Why did I say that? I don't know. Getting old, forgetful. Get quick quiz done, and then the rest of the time you can use working on the big ideas assignment or making corrections on the quiz.
You're welcome.
What? What?